All right, everybody. Let's go ahead and get started for this morning. Um, I think the first thing that I want to talk about is the project evals tomorrow. Tim, would you mind talking about that a little bit, just what we talked about this morning?
I don't mind at all.
Thank you.
So we're gonna do it a little bit different where I think we'll take like the first hour of the morning, and Brian and I are gonna grade the projects kind of without you all around, so we can just kind of go through our rubric and go through your repos on our own. And I think that this is gonna allow us to just kind of like, well, it'll allow us to do a couple things. It'll make the in-person time we have more effective because we can focus all on feedback. We'll come in with a pretty good like understanding of like how the project works before we ever see you, so we won't have to like get familiar with it as y'all are kind of talking us through it. And it'll kind of be like more you all will get to drive the conversation of what you want to talk about and which parts of the project you want to talk about a bit more. And so then this, you can think of like the in-person time as feedback time. And I think that this, me and Brian and I have talked about this quite a bit, and we think that this will be just more useful for you all. So
Yeah, so nothing too different on your end. Still going to sign up for a project eval time. The times will be offset a little bit, but just the actual eval might be a little bit different. We might come in with like scores already for y'all. So yeah. And I think that's about it for housekeeping stuff. Just a reminder that we're going to have those optional final assessments. So I think we've got a list of people who emojied on there. So if you emojied, like be prepared to take that on Friday. Yeah, so let's go ahead and get into a little warm up for today. So let me, so I'm gonna make some breakout rooms and I want you all to discuss a diagram. So I am going to, in the cohort channel, I'm gonna drop a diagram that we did on, when was that? That was, I think that was day one actually. That was Monday afternoon of day one. So it's definitely a little while ago. Okay, so I just dropped that in your cohort channel, and so I've got that diagram. It's the metaphor that that we use for like the internet, and there's a couple questions that I have in there. So I want you all to discuss the questions, and then if you have a little extra time, something else you could do is just go through how does this relate to what we talk about in Mod 2 in terms of the internet. Yeah, does anyone have any questions before I let you go? Give you all 7 minutes to do this. Okay. All right, room should be open. All right, welcome back, everybody. I'm going to take some random volunteers here. Let's hear from Sam. What did you all talk about for the first question?
First question, we talked about when you drop a letter in the mailbox, how does the postal system know where to deliver the letter? So we talked a lot around it, but essentially there should be an address on it and it should target somewhere. And if your handwriting is legible, then someone should be able to read it and send it that way, from the USPS standpoint.
Yep. So we're gonna need this address, right? It's got to be like good, readable. It's got to be in a language that we understand, right? Yeah. Does anyone have anything they would like to add to that first question? I'll throw like a little bonus at you. So when a like mailman is going to like a mailman's got that address, like how does the mailman know where to like what to do with it? They pick it up from your mailbox. Like what do they do with it? Any thoughts? You don't have to go very in depth by a verb. James, what do you think?
Yeah, so I guess like if a mailman picks up a letter from your inbox, they're gonna return to their like domain, or like even prior to that, they'll like go to the hub and then sort it based on like I think I was thinking of an address as like a file structure where like you have the largest is like the world, and then a subfolder of USA, and then a subfolder of Colorado, and then a subfolder of Jefferson County, and so on and so forth. So you'd have to like, if you specify certain information, it'll check that folder and then like search through, and then so then you have like the postal service routes that know how to like get from A to B based on like just how they have it set up.
Yeah, so the postal, like, I don't know how the postal system works like very deeply, but there's like some system under the hood that they just like they're part of, and it's once it's in the postman's hand or the postwoman's hand, then it's just in the system and it goes to where it needs to be. Use the word hub, and maybe another word that I might use is like a router. So like we get the letter goes to like the local post office, and that is like from there they need to route it to the next place. So like you said, maybe, well, if they look at the state next, okay, well, the next thing I need to do is send it off to like Louisiana or something. And then once it gets there, that post system decides like, okay, well, now I need to send this to like the county post office, and et cetera, until we finally get to that house or whatever address we're sending it to. Yeah. What about the, I'm just gonna ask you all to drop in the chat. How many street addresses do you have memorized? 1, 3, 0, 10, 5, yeah. Cool. So like not all of the addresses that you would ever need, right? Like there's gonna be some addresses that we don't have. So let's go to, when you wanna mail a letter, for the third question, when you wanna mail a letter, how would you look up an address that you don't have memorized? Let's hear from V.
So if you don't have it memorized, you can search for it.
Mm-hmm. Yeah, where might you search for it?
Well, in that example, Google.
Okay, so we could Google an address, right? What else? Can I get some volunteers? Where else could you look up an address?
A phone book.
Phone book, yeah. Anything else? You might have like a personal address book, like you might have something stored on your phone or something, right? So the point of all of this is when we want to mail a letter, we need to address it, right? We need to give it an address, and we don't have all of the addresses memorized. We don't have every address that we'd ever want to send to memorized. So we have to have a way to look up addresses. That is what we need to do, the same thing on the internet, and that is where DNS comes in. So what I'm going to do is I'm going to share a diagram with you. Or I'm going to share my screen with the diagram. And this is where we started. Do I have? Yeah, I do have more down here. Let me give me a second to get my zooms in order. Where did y'all go? There you are. Okay, so in the same way that when we, can I get a thumbs up if you all see my diagram? Cool. In the same way that we need to look up an address when we send a letter, we also need to look up an address when we send an HTTP request. So if I go scroll down a little bit here, here is the, when I left you all, I said, if you have time, like talk about how this relates to the internet, this is what I was looking for. So this is how these two relate. Let me maybe zoom out a little. I can't really see them side by side. Let's do this. There we go. So in our internet metaphor, you are the client. Your letter is an HTTP request. The postal system that's responsible for delivering the letter, that is the internet. Then in the postal system, the pen pal or whoever you're writing to receives the letter. That is our server. They're going to read it, process it, and write a response. A response in HTTP is called an HTTP response. And then the same thing, the internet or the postal system delivers it back to you. So the first thing I want to talk about is what is an address in terms of the internet. Well, an address in terms of the internet is an IP address. So let's make this a little bigger here. And so just to give you all a heads up, I'm going to spend probably most of this class like driving this, and this will be a little bit more traditional where I'll kind of be lecturing, and of course you all will have chances to ask questions. And then in our second hour this morning, I'll let you all do more of a solo challenge. So just a heads up there. Okay, so when we are addressing something on the internet, that is known as an IP address. The format of an IP address is going to look something like this. Let's say 1.2.2.2.2. Something like that. So it's going to be 4 numbers separated by dots. And in the same way that an address in the postal system contains a lot of components, like James was talking about, like we've got the street address, the city, the state, all of that. Each one of these numbers is going to be like specific to a certain, each one of these numbers means a specific thing. I'll just leave it there. So we don't need to go too in depth, and I don't know a ton about IP addresses. We don't need to go too in depth into like what this number actually is, but suffice to say that this is the address of a device on the internet. So if you're trying to send an HTTP request to somebody, you have to know this. Now, when we are sending these HTTP requests, so whenever you use a website, like you go to Facebook or you go to Google or Twitter or whatever it is, you don't go to the web browser and you don't type in like, take me to 165.122.0.2. Like you don't memorize these IP addresses in the same way that you don't memorize street addresses. What you do instead is you look it up in your address book. The address book of the internet is DNS. So DNS stands for Domain Name System. And I'll say this is the address book of the internet. More specifically, what this is going to do is it's going to translate a domain name into an IP address. So in the same way, in our metaphor of the postal system, my domain name, which is just to review what we did from, well, actually, I'll ask you all. So I got this URL that I'm on app.diagrams.net. Can I get a volunteer? What is the domain name in this URL? V?
I think it's the middle there, app.diagrams.net.
Yep, you've got it. That is it. For a bonus point, does anyone know what? By the way, I'm keeping track of all my bonus points. I've got you all tabulated. Does anyone know what the .NET portion specifically is called? We didn't talk about. I don't think we've talked about this in Mod 2. Other examples of this are like .com, .org, .edu. Alex?
This is just a guess, but is it top level domain?
You got it. Yeah. So this is the top level domain. Very good. So top level domain is part of our entire domain name. Essentially what this is doing is it's identifying an application on the internet. And when I say application, really all of our applications are hosted on these servers, right? So it's essentially identifying a server. Now this gets a lot more complicated once you have like diverse architecture where you have like multiple servers, but I'm not going to get too in depth into that right now. Okay, so what DNS is going to do is it's going to take this human readable domain name and translate it into an IP address. In our example here, the human readable name would be like your pen pal. I want to mail my letter to, I want to mail a letter to Tim. Well, I'm going to take my human readable name of Tim Tyrell and translate that into, I'm going to look that up in my phone or whatever and get back his street address. Of course, like the metaphor breaks down a little bit because the street address is a little bit more human readable versus like an IP address. I would say this is more machine readable. What questions do you all have so far? There is more to this. Okay, let's take a 5-minute palm and let's come back at 9:32. All right, as people come back from the POM, if any questions did come up, please just raise your hand and we'll get to them. All right. So something that I mentioned yesterday was this idea of understanding, I don't know if that was yesterday or Monday, whatever. This idea of understanding one layer of abstraction below what you're working on. That's something that Jeff and Marcus talked about on Friday, and I thought it was a very good thing to keep in mind. This is a good example of that. So we write Rails applications, we write at the application level, but it is still good to know what happens on the level below that, which is our sending of HTTP requests and responses. So we essentially write code at this number 3 point right here, server reads request. Our job as Rails developers is to handle requests. We take requests in and then we process them. And that can get very complicated, right? There's databases, there's our views, controllers, there's all of that stuff. But essentially all of that is with the purpose of sending a response back. So you can really think of your Rails apps as request receivers and response generators. So understanding like kind of what goes on around that gives you better context of how your work fits into this bigger picture. I'm gonna go a little bit further into detail into DNS here. And give me 1 second. I forgot to pull up my reference just to make sure I don't miss anything. Okay, so if I'm going to really simplify this process, first I'll do it in terms of this analogy. So if I'm going to like put DNS or the address lookup into this analogy, it would be here, and it would probably be something like step 0. So step 0 would be look up address in address book. So that would be the first thing that we need to do, or we could probably, interchange 0 and 1. We could probably write the letter and then figure out where the address is. But the point is we are going to have to look this up before we even are able to send it. So it's kind of the same thing here down in DNS. Before we can send this HTTP request, requesting whatever it is from the application, we're going to need to go through this DNS process. So how does this DNS process work? I have just a regular server. Yeah, let's take this one. So your computer, when it needs this address, it's going to ask this thing for some information. Where's my text here? And this thing right here, I'm going to label as the resolving name server. That's not right. This is why I have my references. This is just going to be the resolving server. So you can almost think of this as like the CEO of this entire DNS process. This thing is kind of like managing some other processes that are going to go on under the hood. So this resolving server is going to be like the main thing here. Let me put an arrow here. So step 0 of our process is zero DNS lookup. And so what we want to get back from our resolving server over here is we're going to, and let me be more specific here. So step 0, DNS lookup by domain name. So I know if I'm looking at, little sdshop.herokuapp.com or whatever it is, whatever the domain name is, this thing should spit back at me an IP address. And once I've got the IP address, then I'm good. Then I can send my HTTP request. And we're off to the races. Typically, this resolving server is managed by your internet service provider. So this is not something that happens on your computer specifically. This is something that happens like within the infrastructure of the internet of like whatever your internet company is. Internet service provider is like CenturyLink or Comcast or Verizon Fios or one of those like big internet companies. Yeah. Oops. Okay, but there are several steps that go into this process right here. And the first one, we'll put another server up here. And so now this is gonna get even more complex. This one right here. So this is gonna be the first thing. So what we're gonna have is this resolving server is gonna ask a series of other servers of where it needs to find, of how to find the IP address, and it's going to keep asking. It's going to start at the top level, like the most general, and work its way down to what is the most specific IP address. In the same way that James was describing earlier, we would start with like, well, what state do we need to go to, and then what county, and then what street, and blah blah blah. Same thing with the DNS system here. So our first most general step that we're going to take here is we're going to go to the root server. And there are, I don't want to get like too in depth into this. Like part of the reason is because like I don't know beyond the fact that it goes to the root server first. I don't know too much about this DNS process, and it's not super important. The root server is essentially just like the first server that we're always going to ask in this process. So I should be able to, nope. So we'll ask this root server for something, and this root server, most likely what it will respond with is it will respond with, I don't know where that specific IP address is stored. I don't know how to take that domain and find that IP address. But what it will know how to do is it will know how to route you to the next server. So in the same way, I might like send a letter to a local post office and they're like, well, like a regional post office, and they would say like, well, I can't deliver that to that specific address, but I can deliver it to the local post office. That's what's going on here. So we would then go to another server. And then this second, slightly more specific server, this one is going to be our TLD server. Gotta be an easier way to do this. TLD, top level domain. So as we mentioned before, the top level domain is that last part in the domain. So it's like .net, .com, .org, whatever. So essentially the DNS system will group domains that have the same top level domain together in these TLD top level domain servers. So root is the most general. You'll just ask the root, no matter what the domain is, ask the root, hey root, what's this IP address? The root most likely will say, I don't know, but it looks like it has this top level domain. So you should go to this top level domain server. And so then we'll go this. And this top level domain server is going to respond most likely in the same way as the root server. It's going to say, well, I don't know where that specific IP address is or where that specific domain name's IP address is, but I do know where the next server that will know what it is. And this is called the authoritative name server right here. So the authoritative name server, the reason it's called authoritative is because it is the authority on where these domains are stored. For authoritative name server. So this thing right here is kind of like our local post office. This is the thing that actually knows how to deliver to that specific street. In our case, this knows where the specific what the IP address is for the specific domain. My arrows are getting a little funky. That's okay. It's not the end of the world. Do something like this. And there we go. So there's several steps that happen underneath this DNS process. And I would say like it's not super important that you all like know everything about like the root server, the top level domain server, the authoritative name server, the resolving server. What you should know is that your computer, when it needs to look up an IP address, it's going to ask this DNS system, and this DNS system is separate from your computer. This happens like out on the internet. So in a weird way, we actually have to send a request before we can send a request. We have to send a request to find where we're sending the request. Yeah. Something else that I want to talk about here, well, let me just make sure I hit everything. Got that. Okay, so I think I'm good here. What I want to, now I'll just talk about this. Okay, so a question that you might have right now is, why is this so complicated? Why can't it just be that this resolving server over here, like why can't we just get rid of all three of these and these resolving servers just tells us where the IP address is? That would be so much simpler, right? And the answer is that sending these requests, so every one of these arrows, these are all devices that are separate from our computer. Physically, they are located in different places in the world. If there was only one resolving server, then every single person in the world would have to hit that same resolving server. So if that is in, if that server is like in Denver, then my requests to that server are going to be really fast. So geographical location does affect the speed of requests. The further away you are, the longer electricity has to travel down these wires, the longer these requests are going to take. So if we just had one, it would be very slow for people that were located on the polar opposite end of the globe. So what we do is we have we have many of these servers, we have many steps in here so that we can route people to more local servers rather than sending them across the world to get this information. The last thing I want to talk about here is caching. And caching is very good for you all to know just in general what this is. So in the same way that I talked about like DNS and domain, I want to take a couple notes on just what caching is. Can I get everybody to give me a reaction when I say caching? Can I get a yes if you've heard the term caching before? So most of you have heard about caching. Let's clear those. Can I get, I won't ask you to do this, but can I get a yes if you feel like you could describe what caching is at a very high level? Yeah, so a couple people, maybe not everybody. Yeah. So caching is too small. There we go. So caching in general in computers, and this is why I want to talk about this because this is not specific to DNS. It's relevant to DNS, but not specific to DNS. Caching is storing the results of a complex operation for later retrieval. And I'll say to avoid, no, I think that's okay. storing the results of a complex operation for later retrieval. So I'll give you an example. If I am doing my taxes, and that's like a very complex process, I have to like go through and I have to like figure out all of this like different information. I won't go too in depth into it. And at the end, I figure out how much I owe the government. If I don't write that number down, and then I need to like put, and I need to, on a different form, I need to put down like how much taxes I owe. I don't want to have to redo all of my taxes to get that number, right? What I want to do is I want to do my taxes once, write down what I came up with, and then just reuse that later. So that is, I would say in that sense, I am caching the results of my tax return calculation, whatever it is. You could also, just a simpler example, you could think of this as math. If I need to calculate the average of 3 numbers, if I need that number again, I don't want to recalculate it every time. I want to write it down so that I can use it later. Computers do the same thing. Computers will store this information. Me writing down was me storing. It will store information so that you can use it later. Can anyone think of an example of caching that you might have seen before, used before in Ruby or Rails? Sydney.
I could be wrong, and I'm going a little off here, but like I just think it's interesting. Like once you when you start working within a file and you like maybe create a name or you're doing something, like as you work within that file, it remembers like what you've called before. So it almost like guesses what you're trying to write based off what you've put previously in that file. So a little off there, I know that, but that's the only thing I can think of.
No, that's great, and I think that gives us a good starting place to talk about this. So that is not quite caching. That's like halfway there to caching, where we are storing the results for later retrieval. But I would say that that's not necessarily because it's a complex operation. So I don't know. You could think of like you typing as like a complex operation, but it doesn't necessarily save computational power. So that's why I might not consider that specifically caching. But thank you for bringing that up. Gus, what do you think?
Is it technically caching, like just the act of like storing variables? Like, so if we say like, at film is, the film with like these attributes, then anytime when we call that film, we have access to those attributes without having to necessarily do like, or if you assigned a variable to like an item in a database, so even like in your controller when you say @item equals, so that like your view doesn't then have to say like, okay server, like do a find by ID and like go in and get this object, so that like local copy, like that's a cached version of that resource.
Yeah, I like that. I think that's a good example. Let me open up Atom here or our setlist app here and kind of just like demonstrate exactly what you just said. So in my controller, I have songs controller. So I've got like song equals song.find params ID. So we know that this line of code for song.find is going to retrieve the song object from the database, right? And then let's look at our view. We store this in an instance variable, and then in our view, we can say @song.title, @song.artist.name. So yeah, I would say this is an example of caching. You probably won't hear this called caching, but I think that this is a good example. Contrast this with if I had this rather than @song equals song.find params. If I just took this out of my controller, and rather than @song.title, I put this in here. Could I run this and see if that still works? Syntax error. Let me fix this real quick. Just comment that out for now. Oh man, Okay, so never mind. I don't know if I'm quite going to be able to get this to run, but I think it still illustrates the point. So if you had this code in your control or in your view where you weren't saving this to a variable, we would essentially be asking the database twice for the same song. So rather than storing that value, that variable for later retrieval, we would be redoing the complex operation. I think that's a good example. Let's hear from James.
Yeah, I'm curious on 2 points. Is caching like in Rails similar to where you're like eager loading information? And also would it be, no, okay, I wasn't sure. And then would it also be maybe like, I know in the application.yaml file, you can set like precompile assets to true or false. Would that be caching if you set it to true, or is that not related?
Also no.
Okay.
So something that I think someone else had a hand up, but it's gone. Okay, so let me kind of let me show you what I'm getting at here. Has anyone seen this before? Let's say like at song or equals. Actually, let's do this. Yeah, let's do this. At song or equals song.find params ID. Has anyone seen this type of syntax before? Could anyone like describe what's going on there? Max, go for it.
Yeah, this is if there is a song, if there is at song, it gives you that at song. If not, it finds it for you.
Mm-hmm. Yeah, exactly. If there's already something stored here in this variable, then we won't do this thing on the right. But if there isn't something here, then we'll do this and then save it into that variable. So the next time that we call this, it's not going to, it's going to have that. Does anyone know what this is called? Joe? Oh, it was a clap.
Yeah, I meant to raise hand actually. Memoization.
Exactly, yes. So this is memoization. And this is something that's very common that you will see very often. And you'll probably see this in mod 3 a lot as you deal with APIs. So this is another example of caching. Yeah, and this is a little bit more specific to Ruby. This is memoization. Yeah, I'll just leave it there. So there are many different ways to cache things. There are many different ways that we can store information for later retrieval. So in terms of DNS, what this is going to look like is essentially that any one of these steps could be cached. And I'll specifically say that it's going to be cached on this resolving name server. So what that might look like is if we start from scratch here, I want to send an HTTP request. Let's say I'm trying to hit facebook.com. So my computer says, we need to look up the address for facebook.com. So we'll ask the resolving server, hey, resolving server, can you get us this address? Normally, the resolving server is going to say, well, I can't give you the address, but let me ask the root server for that address. And the root server will say, okay, well, I don't know where that is. Let me take you to the TLD server. TLD server says, I don't know where that is. Takes you to the authoritative name server that has the domain name. Okay, let's do that again with caching. Computer wants to look up with facebook.com. Okay, hey, resolving server, can you get me the domain address for this? Well, I've already looked up this. I looked this up like a minute ago. So I don't need to go through this whole process again. I have it stored here. I'm just going to give it to you. And so we kind of cut out all three of these servers in that process. The complex operation in this case is hitting all three of these servers. It could be the case that you just cache one step in the process. So you say, hey, resolving server, get us facebook.com. It says, hey, I've already hit the root server for that. I know where the TLD server is, but I don't know where the authoritative name server is. So let's start at the TLD server process. Or maybe it already knows where the authoritative name server is. So it goes straight to the authoritative name server. What questions do y'all have? Mike?
Does the caching ever get wiped?
Yes, so that is a very important problem in caching, is if you just like cache things and you don't clear your cache, you could be storing old information. So for example, what if the address for facebook.com changes? That could very easily happen. We don't want to cache results from like 10 years ago, because then those will get stale, that cache will get stale. So you usually need to like set an expiration for your cache. It depends on what you're caching, but you might do like an hour, or you might do a day, or you might do a week. It just depends on what it is. Another thing that you need to be worried about is like, yes, you should set like a timed expiration, but a lot of times you also just need to check if it's very important that your value is not stale. You need to do some sort of check on, is this thing updated? And what that is called is, it's called cache invalidation, knowing when something stored in your cache is old and no longer valid. There's an old computer science joke about cache invalidation, which I will spare you from right now. You're welcome. Any other questions coming up for you all? All right. Okay, so that's all for DNS today. Thank you all for your time and attention. I'm gonna take a 5-minute palm. Let's plan to come back together at 10:05. Meet back here at 10:05, and we'll kick off our Ruby challenge.